We are going to have a series on carbon capture, sequestration, utilization, and so on. We'll look at the science of carbon capture, the engineering approaches, the natural processes that sequester carbon for us, and the barriers, the finances, the scalability issues, etc. But here we'll start with the history of carbon cycle in the last million or so years, as we have gathered from an ice core in Antarctica, the famous Vostok ice core, which shows nice ups and downs in temperature with ice ages and warm periods, like we are in a warm ice age right now, in the sense there are glaciers around, but we are not in an ice age in a traditional extensive glaciation sense. But nonetheless, when glaciation is extensive, carbon dioxide in the atmosphere goes down by about 100 parts per million by volume, and when the glaciers melt like now, it goes up by about 100 parts per million by volume. Now we are increasing that quantity from the Industrial Revolution onwards very rapidly, and there is the idea of whether increased CO2 helps plants photosynthesize faster, and do they feel like they're getting a fertilizer. There is evidence that it is happening. The question is whether it has also happened in the past, in the sense, is it a natural cycle? This nice study looks at the variations in photosynthetic CO2 uptake using something called O17 isotope. So they look at the data with temperature changes, of course, other things like dust deposition. Basically, they have to separate the impact of other factors like the so-called iron fertilization, because if there is a glaciation and it's drier, then dust can go up and dust can bring iron. If there is iron deposition on the oceans, you can increase photosynthesis, so you can draw down CO2. Right? So if the CO2 is related also to photosynthesis, then basically you have to show that actually the photosynthesis is increasing in its sequestration of carbon when deglaciation happens and CO2 goes up. So that's the negative feedback. If it's warming and you draw down CO2, the warming is reduced. So it turns out that this nice study shows, in fact, there was measurable carbon fertilization during the glacial deglacial periods. So we are running a same natural process now. The question is, will it saturate if we increase CO2 too high, too fast, and so on? Okay, we'll come back and discuss other issues.